Good afternoon, and thank you for joining us for today's webinar, All Confined Spaces Are Not Created Equal. I'm your moderator, Elise Schaefer, editor of Feed and Grain magazine, and here to sort everything out for you on confined spaces today, we have Jess McClure, Vice President, Safety and Regulatory Affairs for the National Grain and Feed Association, and Jim Siebert, Director of Safety, Education, and Training with the National Feed and Grain Association. So once again, I want to thank all of you who signed on for spending part of your busy day with us. And I especially want to thank our sponsors, NewMat Systems, Inc. NewMat Systems strives to eliminate confined space entry whenever possible by delivering powerful equipment and services for safer silo cleaning and bulk loadout activities. NewMat Systems is excited to bring you today's webinar on OSHA's confined space entry standards. And you can learn more about them at newmat.com. So without further ado, I'll turn things over to Jess now.
All right. Thank you, Elise. Can you hear me? All right. Great. We're good to go. All right. Elise, thank you very much for the invitation to give a presentation on this important topic to the industry. What I'm going to be doing here really quick, I know we have a short time here, 30 minutes. So I'm going to give a quick overview of OSHA's confined space entry standards and the grain bin entry standards within the grain handling safety standards. I want to compare those two, and then after I give an overview of the regulatory requirements, Jim Seibert will be then giving a quick overview of grain bin entry best practices. And I know many of you have seen these types of presentations, been through this type of training, but it's always good to get a comparison between the two. And here on this slide, it shows just the background comparing the confined space entry and the grain storage structure. I think, as we all know, 1910.146 for confined space entry that has to deal with all industries, not just the grain industry, that have permanent required confined spaces, and it does not apply to grain storage structures. Now, that's an entirely separate conversation I don't want to get into regarding grain bins that are filled with grain and aren't filled with grain. I know there's you can have a discussion about that, but for the sake of this presentation, just primarily want to cover confined space entry with grain bins that are full. And then you have the grain storage. As far as the grain handling standard, you have the specific parts of that standard, parts G and part H, that deal specific with bin entry. And so the grain handling standard, as you all know, came into effect in 1987, and then it was revised in 1996 to include the flat storage structure. So with that, and I do also know, and many of you are aware, that individual companies do have their own policies too. So many companies may have their own confined space entry policy that may apply to grain bins, but this is the purpose of this presentation is just comparing the difference between the OSHA regulations. So 146, obviously, that this applies to the space itself has to have a size and shape that allows a person to work and enter, limited or restricted opening for entry or exit, and is not designed for a continuous human occupancy. So with that, there's many different types of structures that are found at grain handling locations that this could apply. I know one of them is that there's been much discussion about is obviously with boot pits and how those can vary at different facilities, but there's also different types of confined space locations that are potentially found. So everything ranging from tunnels to receiving pits to manholes as well. So a non-permanent confined space. So as I mentioned, the non-permanent confined space, it's a space that doesn't contain doesn't contain or with respect to atmospheric hazards, it doesn't have the potential to contain any life-threatening hazard. So these types of maybes, right, when you're dealing with a non-permanent confined space, those could be a boot pit, a tunnel, a basement, a control room, these different parts of the facility. And the reason why these are maybes is that oftentimes OSHA may have a different definition, right? So, or a different interpretation, I should say. And once again, this comes back down to an individual facility's process that they use to designate whether this be a permit or non-permit confined space. NGFA, we have numerous educational materials, guidance documents, and so forth that specifically deal with these sections, but wanted to provide this as an example. Permit required confined space, it must contain or has the potential to contain a hazardous atmosphere, has the potential to engulf an occupant, has inward converging walls or floors that slope downward, any other characteristics recognized as life-threatening, right? So all confined spaces must be considered a permit required until proven otherwise. So basically what this is saying is that, difference between a permit and a non-permit required confined space is that from the standpoint of doing the evaluation, you should consider the confined space to be permit required based on these conditions listed above. If they don't meet these requirements, then it would be a non-permit required confined space. And there's also numerous information available on the OSHA's webpage. If you go to osha.gov and look for the Confined Space Advisor, it's an electronic tool where you can then put in these types of situations, these types of conditions that you're dealing with, and it'll provide you with some guidance regarding that classification. So these are the different types of potential hazards within a confined space: atmospheric, mechanical, electrical, obviously within grain bins, engulfment hazards, falling objects, temperature, so forth, conditions that may exist or develop, oxygen deficiency, lockout, weather, and so forth. So these are all the hazards, as previously mentioned, that must be considered when you're classifying the confined spaces, whether it be permit or non-permit required. This document here, it's a bit dated, but it's still available on the OSHA webpage. You have to do a little digging, but you can find it. And what it is, it was from the previous Deputy Assistant Secretary. Through the previous Deputy Assistant Secretary, Richard Fairfax, from the previous Director of the Enforcement Programs. And basically what it did is it described the memo is designed for the OSHA compliance and safety health officers, and it provided them with a clarification on the applicability of the grain storage entry requirements versus confined space. So basically what this was designed is it was designed to educate the inspectors on, when 272G and H, the differences between those particular sections of the standard, how they would apply. So it's a very informational document that it has a flow chart attached with it. We do have that information on the NGFA webpage and through our training material, and that's also, as I said, available on the OSHA website too. Atmospheric hazards, obviously the oxygen concentration level is a very key issue. You can either have too much or too little oxygen, carbon monoxide, hydrogen sulfide, all of these factors primarily having to deal with the quality of grain. Obviously the pesticides with phosphine and the dust, thickness that obviously can obscure vision. But these are critical parts of atmospheric testing, and this is often what leads to some of the challenges that have been that the industry has had in dealing with OSHA regarding the classification of boot pits as being a permit required confined space instead of a confined space. A written confined space program. So obviously an evaluation of all the confined spaces. This is something that, when OSHA, the inspectors will come into a facility, and one of the first things that they always look at, always checking to see if you have a safety and health management program, do you have a housekeeping program? Having a written confined space program is also very important. And so having a list of the confined spaces, the evaluations that have been done, basically the checklist that you've gone through to make that determination. What are the factors that you've considered to classify it as a permit or a non-permit required confined space, and having the signage in the particular areas of the facility where a confined space permit is required. All of this is very important information, not only for the safety and health of the employees and for the general atmosphere of the workplace, but also this is very helpful if OSHA were to come in to do an inspection. The confined space entry training requirements. Obviously, new employees must be fully trained before being part of any entry process, and retraining experienced employees. Those employees that are involved in working or classifying confined space, they may receive training annually or according to the company's policy. So may receive training annually doesn't necessarily mean that that's a requirement by OSHA to have a confined space training annually. But that is something if that's part of the company's policy. Also, any incidents that occur within a facility, it's a lessons learned. Is there anything that occurred within an incident that could be applied to modifying or updating the policy? That's very helpful in learning from that. And you may want to also, since these confined space permits must be filled out, it would be helpful for those workers that are a part of this process to make sure that they take a written test so they can demonstrate the proficiency in their writing skills to make sure that they can properly address the conditions for each confined space. So with that, I'm going to be turning it over here to Jim Seibert, who's going to be talking about grain bin entry.
All right, good afternoon. Let me just start my video here. There, hopefully you can all see me. Thanks to Feed and Grain for hosting this webinar. I'm going to be talking about grain bin entry in regards to the grain handling standard. Materials covering the entry into grain and feed holding structures are covered under paragraphs G and H. The paragraph G covers the top or high-sided entries into bins, silos, and tanks. And paragraph H is going to cover entry through an unrestricted ground level opening or entrance, and we'll kind of see some examples of that a little bit later on in my deck here. So next slide, please. So entry into this grain storage. The first two bullets may raise some red flags for some of you, and that's understandable when we say may issue an entry permit or may evaluate the atmospheric hazards. A lot of you, hopefully it's been ingrained that that's something that you're going to do every time. However, according to paragraph G1I, the employer shall issue a permit unless the employer or employer's representative who would otherwise authorize the permit is present during the entire operation. So that's the caveat to the entry permit. An entry permit is going to be issued and executed if the employer or the authorized person or representative of the employer who would grant permission is going to be available throughout the entry process. And then under the may evaluate atmospheric hazards, that's under paragraph G1III. Atmosphere shall be tested when the employer has reason to believe there's a presence of combustible gases, vapors, or toxic agents. Additionally, it shall be tested for oxygen unless there is continuous air movement before and during the period the employees are inside. So if you've conducted some analysis and you've conducted atmospheric testing and you've documented that testing and you've proved that, hey, there's no atmospheric hazards, then that evaluation prior to entry may or may not need to take place. It may need to take place if you've proven in the past that, yes, atmospheric hazards could be present. If you've tested in the past different times, and you've loaded and unloaded in different time frames of how long grain's been in there, it may not require testing if you've never had negative results on your monitor. So ensure workers will not be exposed to mechanical hazards by locking out all equipment. That's imperative. That piece right there is that's lockout, tag out. We can reduce those entanglements and engulfment issues by restricting grain movement to only move when we cause it to move. Check that no grain hazards exist, such as grain hung up on the sides, too steep of grain mass, so grain beyond the natural angle of repose, and a good inspection of the space prior to entry. Spotlights from the port of entry are encouraged. That way you can see the top of the bin, you can see all sides of the bin, sticking your head through the entrance to make sure that there's no grain directly above or hung up, and make sure that the condition of the grain on the inside doesn't pose a risk to your entrance. Next slide, please. All right, there we go. So we want to ensure there's no engulfment hazards. We want to turn off those reclaim conveyors or lock them out. Same with turn heads and distributors. So with that locking out, the standard also says you could block. And so in some instances, that could mean if you have a sump hole with a conveyor going underneath, or if you have a subfloor auger grating to be installed above those, that's a block that would reduce the risk of an employee coming into contact with that equipment. So walking down grain, that is prohibited within the OSHA standard for both paragraphs G and H. Workers must wear a full body harness and lifeline when on grain over waist deep, and be secured so they cannot sink into the grain any further than waist deep. So there's an exception and separate note to this, where the employer could demonstrate the protection is not feasible or creates a greater hazard by wearing it. The employer can provide an alternative means of protection, preventing the employee from sinking further than waist deep. So that specific point right there, having witnessed a situation like that in bins where you may have thermocouple cables, temperature cables inside of the bin, and if you're entering from an unrestricted side and that's your recovery method, those cables, especially with multiple entrants into the same bin, say you have a large bin and it's a clean out time, you have 6, 7, 8 employees going in, multiple cables create an entanglement hazards that could get an employee into a precarious situation. So the burden of that proof is on the employer. And so on that separate note, so I provided the exception to that. On the note, when an employee is standing or walking on a surface which the employee demonstrates is free from engulfment, just can you back up? There you go. Hazards, the lifeline or alternative means may be disconnected or removed. So just make sure that you dive in to that specific section of the grain handling standard and put a lot of thought into how you want to execute that those entrances, because no one bin is the same as the next bin, and there could be other hazards. There was a fatality that I'm aware of where the lifeline or the recovery line of the employee was dragging across the floor and accidentally slipped through a blocked or a graded subfloor auger. So there's a situation where that line posed a greater risk than not having that line present. So just take those kind of things into consideration when you're looking at your program and you're assessing each individual space. So last bullet, workers got to be over 16 to enter a bin and perform work under the Ag Hazard Occupational Act. Next slide, please. So standby observer must serve as the attendant, ensure proper practices are followed to help the entrance, monitoring conditions, and keep the worker secured. Also, they got to be trained in rescue procedures and notifications for obtaining additional assistance if needed. So the observer is not to go into the space and conduct recoveries of the personnel in there. So they're on the outside to monitor both the internal and external conditions, and be ready to take action should a situation present itself. Also, if a worker's on the inside of a bin and grain is moving and people are shoveling and cleaning out or brooming, more times than not, they are able to see things a little bit better when a worker is focused in an area. Employee got to be trained in hazards of engulfment and avoiding mechanical hazards, and that training's to be given annually or when there's changes in a job assignment. So if you're onboarding and you're training employees to be an observer on the outside or an entrant or an entry supervisor, those three different positions on all grain entries, they've got very specific different duties. And so some companies would deem that each one of those duties is different of different training and different testing to qualify for those positions. Next slide, please. So if you're entering a bin, any type of grain above the grain, you're going to follow G. If you're entering at the bottom through unrestricted ground leveling, that is paragraph H. You can turn on aeration or use forced air fans to ensure there's no question about atmospheric issues. And that's a pretty common practice. You can take a space that does have issues, and by using fans for a period of time, you can get fresh air inside of the bin. Those are pretty common practices and ones that are encouraged. Next slide, please. Okay, so these are the pictures I was talking about earlier. A 2-ring door, 5 foot, is available most new tanks. So, and you can have your company's engineers or outside engineering firms take a look and provide these different types of doors that really provide easy access to and from. And that's you identifying hazards. If the manhole, if it's an 18 or 24 inch hole that's halfway up the side of the tank that you have to be on a ladder to get to, and then you're squeezing through a hole before you come to another ladder and have to go down, there's hazards that are in that specific situation. If your site is available to or it's able to have these types of doors, you can change hazards through these engineering controls, and just take a look at those options, because there's plenty of companies out there that can do this for you. Next slide, please. All right, so education and training. I just wanted to highlight that there's on the ngfa.org/safety page, there's 2 specific bin entry safety videos that the NGFA has produced over the past year. One is on just bin entry safety in general, takes through the beginning steps, the permitting process, testing, and the lockout, and all the processes. It's a short video, about 5 to 6 minutes, that really highlights those main points prior to an entry. And then the second video, the NGFA, we believe that safe bin entries begin on the farm, and on the farm by meaning grain quality control. Engulfments, that's a direct reflection of grain quality, out of condition grain, and creating those hazards inside of a bin, and as well as engulfments are directly tied to equipment being operated while inside of a bin. So those 2 videos really address those points. Training and education continued here on the same page. There's a whole slew of safety tip sheets. You can kind of see hazard communication, proper glove selection, creating emergency action plans, lockout, tagout. And then we have a guidance document for confined space and boot pit evaluation for grain elevators. So you can utilize this document, and that will help you conduct assessments at your facility for those space. This is non-permit required, this is a permit required confined space. So we encourage you to take a look at that. And here's one of the first safety tip sheets in the sloop, preparing bins for harvest. This is a good one to share with your local producers as well as at your facilities. It's a 2-page document that focuses on the absolute necessaries of conducting a bin entry. Next slide. And just more information, we got these training videos that Your Safety Matters. And here's the opening of the bin entry safety that we produced this last year. And it's great information, so please check it out. Next slide. And with that, this is the end of Jess and I's presentation, and we'll open it up to questions for those who are attending.
Okay, thank you, Jim, and thank you, Jess, very much. I really appreciate all the time and effort you put into that presentation. There's a lot of actionable information in there and a lot of websites and resources for our audience. So just want to remind everyone, you can use the chat window to submit questions. And we did have a few that came up during the presentation. One of them was regarding the amount of time that you should do atmospheric monitoring before you've determined that there is not a hazard. Are you talking 6 months, 3 months, even less time? What do you recommend?
So can you hear me?
Yes.
Okay. I don't know, Jim, do you want to go first on this or?
So Jess, unless there's something that is not coming to my mind here. So the amount of time, one, I would take a look at what is the turnover rate for your bins. Okay, so if you're putting grain in there and you're going to store that grain for 8 months, hey, there's a good opportunity to create a foundation, and you can that gives you good information to use in other scenarios as well. So I do not believe that there is a time a time min or max that you have to do this for. I think the important part is, getting a little bit of outside guidance from your company if you don't have the resources within it that say, hey, what's a good window? We're going to do this window. We're going to do it with bin empties. We're going to do this, half full, all the way full. If we are holding grain for more than 2 months before that bin is turned, what is going to give us the best sample data? Because ultimately the burden of proof is going to land on the employer and on the facility management in case of an inspection or in case of an incident. And so go ahead, Jess.
And I was just going to add, and I think something else to add into that too, is that you have to remember, according to the grain handling standard 1910-272G, technically OSHA does not actually require an atmospheric testing before entering a bin. So a lot of people don't seem to realize that it is not actually required by OSHA. OSHA says you should do an atmospheric testing. It doesn't say shall. So what that means is just to kind of to throw into what Jim is saying, I mean, it gets back to the company policy, right? According to OSHA, OSHA doesn't have to say it's specific, but it is something that is, I would say, strongly suggested. Is that correct, Jim?
Jess, that paragraph that I read earlier, paragraph G1III, it does say that they shall be tested when the employer has reason to believe there is presence of combustible gas, vapors, toxic agents.
Correct.
So it says it shall be tested when the employer has reason to believe. That reason to believe, that is why those assessments are critical. So would I say that I don't encourage testing with an air monitor every single time before entry? Absolutely not. I would recommend that you do that because that is the safest option. If you choose to not do that, you have got to have conducted an assessment and have that to back up you having reason to believe that there's nothing there. And so that's a liability issue that I would put back on the employer, that your assessment is your responsibility to do. It gives you flexibility if the employer has a reason to believe that none are present. You've got the burden of proof to prove that. So that's where the assessment comes into place.
Okay, so it sounds like there are a lot of individual circumstances involved in that answer. So thank you for sharing all those various circumstances. We do have a lot of questions, and so I'm going to note that just in the with time in mind, what I'm going to do is forward any questions that we don't get to Jim and Jess to see if they are able to answer them. But I will ask another question right now. What about locking out the sweep auger for entering an empty flat bottom bin with a 2-ring door?
I would think that, right? I mean, my initial thought is you would be locking it out if it's not in use anyway, correct? I mean, it's similar like to a lockout tagout policy. Is that?
Let me say the question back to make sure that I got it. What about locking out a sweep auger that there's no grain in there anymore? Is that the question?
Yeah. I would.
Okay, so that's it depends on the type of sweep auger, number one. So is this a sweep auger that's up to the new fancy ones that have they can only be operated from if you're behind it and you're controlling the switch? Is it that type, or is it an old school kind of dangerous sweep auger? I guess it depends on the sweep auger, number one. But number two is if you're stepping into a bin right next to whether there's grain present or not, you're stepping next to an open machine that now you're exposed to an entanglement hazard. And so dependent upon the type of sweep auger that you have, that would kind of answer the question. If it's one where you have to be in a protected cage behind the sweep auger and you have to insert a key and you have to have your foot on a pedal and it keeps you within a protected barrier that if you leave, it shuts off immediately, that's the type that I don't think you need to lock out. But if it's one that could start at the push of a button controlled on the inside of the facility as soon as you step in there and there's no guards in place, then absolutely you've gotten a live entanglement hazard that could start not under your control. I don't know if that makes sense or is clear, but I think that it's dependent on the sweep auger.
I think that's very clear, Jim, and I think it kind of gets back to the point where you're saying it's like where can it be started? You know, if you had somebody inside the bin, and just like you're describing the incident that occurred, right? That if there's a hazard, you know, whether it's switch inside or outside, and there's a hazard of somebody in there, it would make sense to have it blocked out. Correct? Yeah.
Yeah.
Okay, thank you. I do have one last question. With all regulations, including OSHA regulations, changes are ongoing, they're being evaluated. Is there anything on the immediate horizon that our audience should know about pertaining to confined space or permits?
I'm not aware of any upcoming changes to the current OSHA standards. Now, I do know there are several state plans, right? You know, many of those within the industry are in state plan states. For example, Michigan's a state plan state. Iowa's a state plan state. At a minimum, they have to meet federal OSHA requirements. But if they wanted to, they could make changes to their standards to be, you could say, more restrictive. For example, California, OSHA, they actually have their own separate standard for flat storage in California. So, but as far as anything at the federal OSHA level, I'm not aware of anything coming down the pipe regarding changes. But once again, a lot of this is just what we're talking about here is based on an interpretation. For example, an OSHA inspector, right? You know, what's something that I know has been a challenge for the industry is an OSHA inspector may interpret a tunnel or a boot pit to be a permit required confined space while going through the checklist that we've discussed. The facility may not determine it to be a permit required confined space. So that's usually the challenges that are primarily faced is based on OSHA's individual interpretation at individual facilities. Jim, is there anything to?
No, I agree.
Okay, thank you very much for that explanation. And with that, we are all out of time. I appreciate this dialogue and all the discussion we had here. Thank you, Jim and Jess, for your presentation. And thank you, Numat Systems, Inc. for sponsoring today's webinar. Please keep your eyes peeled in your inbox for the recording of this webinar. At the end will be the slide with Jim and Jess's contact information. And please join us on July 15th for our next webinar on managing multi-generational workplaces. So once again, thank you everyone and take care.
Thank you.
Thank you.